So this week, we're going to take a look at what are called logarithms. This is a topic that you might have done in Algebra 2, but chances are, because last year wasn't quite the same, being the hybrid, you might be a topic you didn't get to. So it's in Chapter 7. It's not necessarily trig, but it's an easier topic to do, and it is in our book. So it's hopefully a topic that will boost your grade a little bit. Okay, so we're not really going to see too much sine, cosine, tangent in this section. But again, it's kind of an easier topic without getting into something too complicated right before break. All right, so what a logarithm has to do with is it allows you to be able to solve equations that have certain things in them, okay, that you can't necessarily solve with Algebra 1 or Algebra 2. So let's take a look at an example. Here's an equation that hopefully you could solve without anything too fancy. Saying 2 to what power gives you 8? Anyone think they can tell me the answer to that? Pete?
Cubed.
Yeah, 2 cubed. 2 to the third power gives you 8. Now, the reason that one wasn't too bad is because the number on the right-hand side is a power of 2. Now, if I did this, I didn't change the equation that much. All I did was make it 2 to the x equals 9, but I've made it a lot harder. Because 2 cubed is 8. So an exponent of 3 is too small, right? Let's try the next exponent, 2 to the 4th. What's 2 to the 4th power? Yep.
16.
16, that's too big. So now the answer is in between a 3 and a 4. How would we figure that out? That's what a logarithm allows you to do. Solve an equation where you have a variable in the exponent. And this, the thing I just circled there and that thing there, those are called exponential expressions. So it's an expression that has a variable in the exponent. Not something that you see in Algebra 1. In Algebra 1, you might have something like this. You have a variable, but it's not in the exponent. That's very different. There's a couple more examples of exponential expressions. 2 to the x, 3 to the y. Anything with a variable in the exponent. Now, once you take something like that, okay, that's an exponential expression, and then you throw in an equal sign and put a number, now you've turned it into an exponential equation. Okay, once you put an equal sign, it turns into an equation. Okay, but this all by itself, that's just an exponential expression. And when we have an exponential expression that's a little bit harder to solve, okay, like this one. If you tried to figure it out, you could try, well, if x is 2, 2 to the second power gives me 4. No, I'm trying to get 5. Let's try the next number up. 2 to the third power, that gives me 8. Oh, well, that's too big. So how are we going to solve it when the exponent isn't a nice number? When it's in between two of them, what are we going to do? We're going to change what we have into what's called a logarithmic expression. And once you change something into that format, then you can type it in on the calculator and solve it. I don't think we're going to do too much with the calculator today, but we will by Tuesday and Wednesday. So let me show you the formula to change something between what I'm going to call exponential form and log form. Now, this formula doesn't really involve any calculations or any math. This formula is more of rearranging. That's all it is. taking and putting things in different spots. And you don't have to do any math to convert between log form and exponential form. What I have on the left is something in exponential form. If you go back and look at like an example I had, you've got a base, you've got an exponent, and then you have a number by itself on the other side. Same thing here. You've got a base, you've got an exponent, and you're going to have something by itself on the other side. So what's on the right is called log form. Okay, that's the logarithmic version of the equation on the left. And the way you can tell that something is in log form is, first of all, it has the word log. Okay, you see that right away. We had 3 different letters on the left, and there's 3 different letters on the right. I think I said this. But when you have something with a number up higher and a number or something lower, does anybody remember, what do you call the thing that's lower? Begins with a P. Yeah?
Base.
That's your base. That number was lower, so we call it the base. How about the thing that's higher? What's the word for that? Yeah?
The exponent?
That's an exponent. When you rewrite something as a log, this was originally called the base because it was lower. This is also called the base because it's a little bit lower. If that was, say you had lined paper on the right-hand side, that's what it would look like on lined paper. The y, the equals, and the log would be right, and the x are right on the line. The a is actually what we call a subscript. The a would be below the line. Anything we put below the line, that's called a base. Okay, it's lower, think of like the base of something. The base is on the bottom, it's lower than everything else. So the base that was on my exponential becomes what we call the base on my logarithm. Okay, and I'll talk about what the base means in a little bit. All right, the next thing. The logarithm equals y. What was y originally? It was the exponent. So logs always equal an exponent. Logs always equal an exponent. So if you can remember that, logarithm always equals the exponent. You look at your problem, say, okay, my exponent was a y. What is the logarithm going to equal? It's going to equal the exponent. The exponent was a y. Logarithms always equal exponents. And then this right here is called the argument. Kind of hard to see, but in blue it says argument. The argument is just the thing that you are plugging into a function. So when we dealt with things like sine and cosine, like sine of 10 degrees, we would call 10 degrees the argument. It's the thing that you're taking the sine of. Or if you had square root of 12, you could call 12 the argument. It's the thing you're taking the square root of. Well, x here is the thing I'm going to take the log of. When you plug it in on a calculator, you have a button for log. If I press log, I could type in the number 20, hit enter, and you get an answer. What we just did there is we took the logarithm of 20. Again, I'll explain more what logarithm is, but 20 is the thing I took the logarithm. Okay, it's called my argument. And the way you can remember that it's the argument is, look at where it is right there. Okay. It's on the left-hand side. Now, what happens if you argue with somebody all the time? What's going to happen if you argue with somebody like every day? Eventually, what do you think happens? James?
You're going to want to stop arguing with them?
It would be nice. The other person's probably going to want to stop arguing. And what if you don't stop arguing with them? What do you think they're going to do?
I have no idea. Like, I have a few ideas, but none relate to math.
So, how about a rational person? Like if you let's say like you argued with me every single day, what do you think eventually I'm going to do? If it was during class?
Probably fail me or get mad at me.
Well, I'm going to fail you unless you fail yourself on your test. But I'm not going to give you a grade that you didn't earn. But let's say if you're disrupting me every day by arguing with me, eventually I need to teach everybody. So what am I going to have to do?
Kick me out.
You're going to have to go somewhere else, right? You're going to end up by yourself. So if you argue with somebody all the time, that person's eventually going to get annoyed. And what's going to happen to you? You're going to end up by yourself. So if you look at the argument here on the left, it's all by itself on the left-hand side. That's how we know that this is called an argument. It's the thing that's all alone. And that's how I remember it. If you argue with somebody all the time, you're going to end up alone because they're not going to want to be around you. They're going to tell you to go somewhere else. Right? So argument is all alone. All right? So that's how I remember. Argument's all alone. All right, so how do you read what's on the right-hand side? How do you pronounce it? Okay, so that is how you pronounce it. You say y equals log base a of x. You read it left to right. It's just when you get to the a, because it's lower, you have to say base a. And what does the base really do? Well, it's kind of like this. What is this thing right here? If you were to read that to me, what is this in math? This little symbol with a 3 above it. Yeah? That's a cube root. What's that? Let's see. What kind of root is that? It's nothing fancy, really. Just a number. Pete?
Or root?
Fourth root. Yeah, it's a fourth root. So this is a cube root. This is a fourth root. All that this number does is change the type of root that you're taking. Well, that's all that the base does on a logarithm. That's a base 8 log. That's a base 2 log. They're just different types of logarithms, just like you can do different types of roots. They're still logs, just with a different base. And we'll learn how do we type that in on the calculator. Okay. All right, any questions on how you write a logarithm? Like where the spacing is between the a, the x, or how you pronounce it? Okay, so let's try this. So the goal here isn't to solve anything. It's really just to rewrite it. So they want us to change that into exponential form. Remember, exponential form always looks like this. You have to figure out what goes in the 3 boxes. Let's start with the 3. Anybody remember what the 3 is called? It's low. So that's my, yep, Johnny? That's my base. So when I rewrite it, it's going to become my base as an exponential. Where does the base go? Goes right there. So that's my base. All right, so we got that one. So sometimes I just check it off to remember, okay, I did that. Okay, next thing. Logarithm always equals what kind of number? I wrote that in green off to the side. Logarithm always equals the exponent. Logarithm always equals the exponent. So y is my exponent. So that's y. So we got that. And now the last thing is the x. And that's what you're plugging into the log function. What do we call the thing we plug in? Yep.
Argument.
It's the argument. And what happens to the argument? It ends up all by itself. So that's the argument. And it ends up all by itself on the other side. And that's it. That's your answer. Okay. If you knew what y was, then you could go ahead and finish solving it. Like if y was 2, then you could do 3 to the second power and get 9. But that's all we can do. Questions on that? Okay. All right. Let's try this one. Same directions, change to exponential form. Okay, Ben, what's my base here?
5.
5. Okay, remember, if this was lined, those would be right on the line. The 5 is below, subscript. So 5 is my base. How about Jaden? Logarithm always equals what kind of number? And what type of thing does the logarithm always equal? That's what I wrote off to the side in green. I said earlier, logarithms are always used to solve equations when the variable is up in the exponent, right? So logarithm always equals the exponent. So in this case, exponent is y. Okay, only thing I have left. Dominic, what do we call the x?
Argument.
Argument, and where does it end up? All by itself on the other side, separated from everything else. Now, notice this one, did I do it different? No, I did it the same. If you wrote it like that, or you wrote it like this, that's the same thing. It's like x equals 2, 2 equals x. You can write it in either order. Okay, any questions on that one? All right, so that's changing to exponential. Let's try the other way, changing to log. Okay, Raymond, if I'm going to change to log, the log version, what do you think I have to write down first? Even before that, what's the key thing you can notice and say, oh, that must be log form because it has... Without this, it's not log form. You have to have this in it.
Base.
Well, the base is going to be part of the thing, but you need to write the thing down first so you have something to put the base with. Yep.
Log.
Log. You have to have the word log. Okay, so that's the very first thing. Anything in log form is always going to look like this. Log equals, and then you have to fill those three things in. All right, so we got the log. How about something else here? We could do the 3. You know, what's the 3? Pete?
3 is the y.
And where does that go?
Which means he's on the other side of the equal sign.
Yeah, logarithm always equals an exponent. So look up what your exponent is. 3. Okay, so we took care of the 3. What about my base on my log? The base is what type of logarithm I'm doing. I'm doing a log with a base of, yep,
1.2.
1.2. 0.2. Right? And Mateo, the thing that was all by itself, the m, what do we call that?
Argument.
That was the argument, and that's what you're plugging into the log function. Okay? It's what you're taking the log of. Again, it's a variable, so we can't do it, but if it was a number, we could. That's how you rewrite from exponential to log. Okay, questions on that? Okay, I think I have more of those, maybe two. Let's look at this one. E to the b equals 9. Here's Autumn. What's, if I want to write something in log form, what's the very first thing I should do?
Write down log.
Write down the word log. Log is the name of a function, just like SIN or COS or TAN. It's the name of the button you're going to press on the calculator. So it's a logarithm, right? And yes, logarithm always equals what kind of thing?
The exponent.
Always equals the exponent. And in this case, my exponent is
B.
b. Okay. Katrina, what's going to be the base on my log?
E.
E. E was the base originally because it's lower than the exponent. E is going to be lower than the log. So we're going to make that my base. And 9 is my argument because it was all by itself. Right, so that says b equals log base e of 9. That's how you pronounce it. Okay, any questions on that one? All right. All right, let's try one more where we change back to exponential. Okay, just make sure we remember how to go back the other way. Okay, let's start with my base. Jody, what's my base here? E. And Ava, what do we keep saying? That a logarithm always equals what kind of number?
I forget. My brain's not really working today.
That's okay. Anyone help her out? What is it? Logarithm always equals the p?
Exponent.
Exponent. Logarithm always equals the exponent. So in this case, exponent is a -3. Right? And Vivian, what's going to end up all by itself in that box?
The argument.
The argument, which is?
Is it -3?
Nope, that's my exponent. Logarithm always equals the exponent. So once you've written something down, that's used.
B?
B. The argument, I mean, that's the thing that you're plugging into the log function. It's like if it said sine of 10. 10 is what you're plugging into the sine. B is what you're plugging into the log. So B. And that's actually something we could do out and get an answer. And you might look at it and be like, well, wait, how can you do it out when you have a letter? How do you know what E is? Well, E is not just a random letter. If you say E is a random letter here, that's like saying this is a random letter. Not in math. Yes, it is a letter in the Greek alphabet, but it stands for 3.14 in math. Well, E is a letter in the English alphabet, but it stands for the number 2.718. It keeps going. But that's what E is. So not as many people are familiar with E, but E is actually a number just like pi is a number. Might look like it keeps repeating 1828, 1828. It doesn't. I don't remember what the next number is, but it's not 1828 again. So if you actually wanted to know what this came out to, you'd have to use a scientific calculator that had E, or you'd have to memorize that number and raise it to the -3rd power. So if they wanted an actual answer, it's 5 if you were to round it. Again, that wasn't the goal of this problem, to solve for the actual answer. They just wanted you to change it to an exponential expression. But it was kind of a good time for me to bring up about e, because it came up. We'll talk more about e in a little bit. Question on that one? All right. So now, this is one that they want us to solve. Okay, so they're actually, when you're done here, they want to know the answer. X equals 7.5, or whatever it is. Okay, they want to know what to get. Now, what's the only thing that we've learned how to do so far if you have an equation in log form? There's only one thing I've taught you how to do. Yep?
Write down log.
Well, that's if you wanted to change it to log form. But this already is log form. So what do you think we can do with something that's already in log form? And we've done it today a few times. Yep?
What if you just solve it the way it is?
Okay, how would you solve it?
I don't know that part. I just know how to solve it.
So we can't solve it the way it is. We have to change it so we know how to solve it. Basically, we don't want to have the word log in there. If we can get rid of that, that would make it easier. Yep, Andrew?
Convert it to exponential form.
Yeah, let's convert it to exponential form and see what it looks like. Can you tell me if you convert that, what it would be?
2 equals...
Well, let's start with 2. What is the 2 there?
base.
That's the base. So we're going to have another number up here, because without that other number right there, it wouldn't be a base.
Yeah.
So what number has to go there?
16.
What do we call the thing that's going to go in that box? It's my
Exponent.
exponent. And remember, logarithm always equals the
Exponent.
exponent. Yep. So in this case, my exponent will be
X.
x. Good. Okay. So 2 to the x. Got my base. Got my exponent. And the 16. Aiden, what do we call that?
Argument.
Argument. And where does that end up?
And by itself.
All by itself on the other side. So now this question is basically just saying 2 to what power gives you 16? And that's the answer. What is it? 2 to what power is 16? Yep. 4th power. This is very similar to the kind of equation I showed you right at the beginning. Now, if that was a 17, we'd have a problem. There is a way to do it, and we'll learn that on Wednesday. Okay, but for now, it's going to have to come out like that. Don't thank me yet. No, this lesson's pretty easy. It builds, as we go on tomorrow, it builds a little bit more, and then Wednesday it builds a little bit more. Okay, let's try this one. Okay, it's an equation in log form. The only thing we know how to do is change it to exponential. So let's give that a shot and see what happens. How about, again, what's the 5 here?
Base.
That's my base. In order for something to be a base, it needs to have a number on it that is an exponent. What's the exponent in this case, Ava?
X.
X. Okay. And Jaden, what's going to end up on the other side? The argument, which in this case is 25. Again, another one that's not bad because 25 is a power of 5. Brandon, what power can you raise 5 to get 25?
2.
What is it?
2.
Yeah, 2. And there's your answer. Okay. Questions on that one? Right, another one that's kind of the same setup. Log base 3 of 127 equals x. Okay, log base 3 of 127 equals x. Pete?
What is it, 3 to the x equals 127?
Yes.
1 over 27?
Yep, 1 over 27.
Well, that is 1.
Now, let's pretend for a second it was this. It's not that. But 3 to what power would give you 27? Jody? The third power, because 3 times 3 times 3 is 27. Now, we don't want to get 27 in our problem. We want to get 1 over 27. So does anybody remember what kind of number the exponent has to be to cause something to flip? James?
Negative.
Has to be a negative. So the answer here isn't going to be 3, it's going to be
Negative 3.
negative 3. Remember, if you raise something to a negative exponent, it causes it to flip. And that's what happens here. So this really means that. And 3 times 3 times 3 is 27, and that's exactly what we wanted. Right, so if you see a fraction, then the exponent is going to have to be a negative. But if you can't figure out the number it should be, think about it like it's not a fraction. Say, okay, if it wasn't a fraction, it would be 3. But it is a fraction, so it's negative. Okay, any question on that one? Okay. All right, so the letter E. Yeah, kind of, I already did this, but we'll just write it down formally. So again, E is not anything we should use in this section as a letter. Okay, if we need to pick a variable, like if we were doing a word problem, don't use E. Because E already means something special. It means 2.718. And we saw E a little bit earlier before I even told you what it was. If we go back just for a second to, let's see. Well, we saw it in, in example 3. I think we even saw it before that. Right here, example 2b. You would never actually see something written like that, log base E. Because when you put a base of E on a log, that is something special. Okay? It has a special name. And I'm going to show you what that is. So if you ever see a base of E on a log, just like I circled before, you never actually write that. It's one of 2 special cases with logs. If you have a base of E, you can take what I just circled in red and abbreviate it with that. Lowercase l, lowercase m. So you can write that, it's just nobody does. Log base E is abbreviated as lowercase l, lowercase m. And the reason they use those 2 letters is because LN stands for natural logarithm. Why didn't they do NL, natural logarithm, instead of LN? I don't know. But that's what they did. So if you have a log with a base of E, you can abbreviate that lowercase l, lowercase n. You don't do anything to your argument. You write that just the same. So no change to the x. It's just how we write what comes before it. One thing you have to be careful when you write something as lowercase l, lowercase n, you might forget what the base actually is. because that in that abbreviation, when you write it in that style, you don't have to write the base anymore. It's hidden. The base is still E, right there, but you don't write it. It's hidden in the abbreviation. So, I mean, it's not a huge abbreviation, but it takes something that was 4 letters and it turns it into 2. So it's half as much writing. And that's called a natural logarithm. So a logarithm with a base of E is called a natural log. And there's a button on the calculator, and it's on my calculators as well. On this one, it's near the 4, and if I press it, it puts lowercase l, lowercase n on the screen. It's right near the 4. There's one other thing. Okay, I mentioned it in a little bit. So I'm going to hold off. I'll mention something else in a minute. All right, so let's change this to an exponential expression. Now this is where we have to remember what the base is. Okay, because in an exponential expression, we need 3 things. The base goes right there. The base is invisible. It's hidden in the abbreviation. But what is the base of ln? What is the base of the natural logarithm? Yep. E. So E is my base. And this is still a logarithm. It's just instead of writing log, it's a special type of log. It's called a natural log. But still a log. Logarithm always equals what kind of number? Exponent. So 8 is my exponent. And the thing we're taking the natural log of in this case is x. And what do we call the x? It's the it's the argument. And the argument ends up by itself. Okay, and that's something we could type in on the calculator. Press your E button, exponent, 8, and then hit equals. In this case, that wasn't the goal. They just said change to an exponential expression. So we're done. Okay, questions on that one? All right. So kind of the same, just a different number. So it says natural log of x equals 12. When I pronounce that, a lot of times I'll just read it as ln x. If you want to read it formally, it would be the natural log of x equals 12. Okay, anyone think they could tell me how to rewrite that in exponential form? I need a base, I need an exponent, and then I need something on the other side. Yep, Jane?
E and then the exponent of 12 equals x.
Equals x. And the most tricky thing again is you have to remember the base is hidden, but it is an E. Okay. Questions on that one? All right. So I mentioned that natural log is a special type of log. Okay, and it has its own name, natural log. Well, there is one other special case. This is the only other logarithm that has a special name. And if you use a base of 10 on your logarithm, that is called a common logarithm. Base 10 is a common log. That's an example of a common log. Log base 10 of 5. So if it's base E, we call it natural log. If it's base 10, we can call it a common log. If it's any other base, and they say, well, what is that one? We just say, oh, it's log base 2, log base 6, log base 5, log base 9, whatever it is. There is no special name. Just 10 and E. Yep. there's a little bit of an abbreviation, but not quite as much. You can actually do that. And you might think, well, wait, you didn't put the base. You're right, I didn't. If you ever have a logarithm and the base isn't there, you can assume that it's base 10. That's the only abbreviation there is. So if you see a problem that says log 40, they are assuming in that problem the base is 10. So if the base is ever left blank and you have the word log, you assume it's a 10. Just like if you have a variable and you don't put a number in front of it. What number do we always assume is in front of a variable if it's not there? Yeah? A 1. Well, this is the same idea. If you don't have a base, we assume it's a 10. Base 10. Any questions on that? All right, so what are the two special names that we can have? Jade?
Natural log and common log.
And what is the base on a natural log? E. And what's the base on a common log?
10.
Perfect. All right, so let's finish up with a few problems. Let me just kind of give you a preview of the last 3 problems we're going to do. This problem has a variable inside the argument. That's all the argument. The next one is going to have a variable, but it's going to be in the base. And the third one will have a variable in the next one. Right, we'll try a few different problems. Okay, so again, the only thing we know how to do with an equation that's in log form is change it to exponential. And then once we change it to exponential, a lot of times it's just an algebra 1 equation to get the variable by itself. All right, so let's start with my base. What is my base? Yep, Johnny? 3. Very good. 3 is my base. Logarithm always equals what kind of number? Logarithm always equals the, yep,
Exponent.
always equals the exponent. And the 4x minus 7, that's what I'm taking the log of. And what do we call the thing we're taking the log of? That's the, yep.
Argument.
And where does the argument end up?
Alone.
It ends up alone on the other side, with nothing else near it. So 4x minus 7 is on the other side. Now we've taken the word log right out of the problem, and from here it should just be an algebra 1 equation to solve. Okay, what do I do first there? Yep.
Stop the exponent.
Okay, what do you get when you do 3 squared?
Right.
9. All right, what about my next step to get x by itself? Pete?
Add 7.
Okay, add 7. Add 7. 9 and 7 will give me 16. And what's my last step to get x by itself? Okay,
Divide by 4.
divide side by 4. And what's 16 divided by 4? 4. There you go. So that's solving a log problem with a variable was in the argument. This one came out to a nice answer, but if this was like 17 divided by 4, we could just put it in on the calculator and write it down as a decimal. But we didn't need a calculator this time. Questions on that? All right, so let's try this one. A little different because now the variable is the base. The variable is not in the argument. So log base x of 64 equals 2. Autumn, what's my base in this case?
X.
X. Mateo, how about my exponent?
2.
2. Logarithm always equals the exponent. 2 equals, and the 64 is my argument. It's what I'm taking the logarithm of. And where does the 64 end up? Yep, it ends up all by itself. Okay. X squared equals 64. How do we solve that? Yep.
You could write it as 2x equals 64 and then divide by 2. That's not great. Never mind.
Yeah, because if you divide each side by 2, you get 32, and if you took 32 to the second power,
Yeah, no.
that would mean 32 times 32. That wouldn't give us 64. Yep.
Take the square root of each side.
Take the square root of both sides. When you take the square of a square root, or square root of a square, they cancel out. And what's the square root of 64? Yep. 8. Now technically 8 times 8 is 64, but what else times itself is also 64? Colby? Negative. When we're dealing with logarithms, that number can never be a negative. If it was, it would be imaginary. And we're not doing that. So technically when you take the square root of 64, there are 2 answers. We're not using the negative one. Okay, so the answer here is just 8. So bases cannot be negative with a log. Neither can the argument. Watch what happens if I try to take the log of a negative number. Log of -5. It doesn't say it can't do it. It says that the answer is not real, which means it's imagined. Okay, so we're not going to ever worry about negative arguments or negative bases. All right. And last one. What format is that equation in? Is that a log type of equation or exponential? Vivian?
Exponential.
That's exponential. If it was log, you would have to see one of 2 words, log or ln. Doesn't have those in it, so that's exponential. Right, so let's change it to log form and see if we can solve it. Aiden, very first thing I have to write down when I'm changing to log form.
Since you go log, I mean, first thing you do is log.
First thing we gotta write down is the word log. Now we gotta fill in everything around it. What goes on the other side? My base and my argument. I usually start with the base. What's my base here? E. Okay, we talked about that already, so we're gonna do something with that in a second. So my base is E. And how about James? Logarithm always equals what kind of number?
The exponent,
Yep. What's my exponent here?
2x.
2x. Yep, this whole thing is my exponent. And now the only thing I haven't used is the 5, and it was all by itself. So the 5 becomes the argument. It's the argument to the log function. It's what I'm going to type in and take the log of on the calculator. Now, I'm doing log base E. What did we say earlier that that's called? Log base E.
Natural log.
Natural log, and how do we abbreviate all of that? ln of 5. Well, if I take the ln of 5, that's not going to give me x. That's going to give me double x. I don't want 2x. So how would I get x by itself here? Yep. Divide 2 on both sides. And that's your answer. Okay, in this case, we will type that in. And here's how you type it in. So we're going to press natural log. Notice it puts a parenthesis. The only thing that I want to take the natural log of is 5. I'm done with the natural log, so I need to close that parenthesis and then hit divide by 2. So the answer there is 0.805. Now, if you don't close the parenthesis, let's say you left it like that, what that's really going to do is this. It's going to take 5, divide it by 2, and take the natural log of 2.5. People see the difference between those two? Okay, you need to close that parenthesis first. 0.805. Well, let's see if it works. Let's take E, plug in 0.805 for x, and see if we get 5. I'm going to take E, raise, I'm just checking my answer, 2 times 0.805. So I just solved for a variable that was in the exponent. I got 5.002, but I was supposed to get 5. How come I didn't get 5? Why did I get 5.002? I got close to 5. Yep.
E is an irrational number, so it can't be exact.
Yeah. Remember, the answer here wasn't 0.805. It's 0.8047189,562, and it just keeps going. It's because we rounded off the answer. But when I plugged it in, it did check out, and it worked. Okay. Great. Any questions on that? Okay. So that's the first part of logs. Again, tomorrow it gets a little bit harder, but not too bad. And then Wednesday, about the same as tomorrow. Okay, so the questions tonight are on 473, 10 to 16, 22 to 28, 34 to 38, and 92 to 98. Okay, and those are all evens. Just the evens on all of those. I think the hardest thing that comes up this week is making sure you remember your Algebra 1. So like quadratic formula or factoring, those two things will come up later on. And if you don't remember that, that's what makes this week hard. Not the stuff I'm teaching you, but the stuff you need from Algebra 1 to solve.